Good morning. This is an example of how you do your array diagramming and mathematical calculations performance task for Science 10. Okay, so this is an example where we involve a lens this time, and we are using a convex lens this time. Okay, so how do you do that? So first of all, you get your bond paper like this, and then you have to make the principal axis. And then once you have the principal axis, you choose a point where you can place your lens, example here, and then make a completely perpendicular line to it. So you have to make sure that this is 100% perpendicular, okay? And this will be your principal axis, and then this line here will be your lens axis, okay? Now since we are doing a convex lens this time, so let's draw the convex lens shape. Now this time this curve doesn't have to be accurate because what is important here is the lens axis. So the shape of the lens um, wouldn't matter, at least for the diagramming purposes. Obviously, if you are going to create a real lens, then of course the shape of the curvature of the lens matters. But for diagramming, it doesn't. Okay. So from here, obviously, where they intersect is called the vertex. And then you get to decide your focal length. So use a reasonable estimate of the focal length or assert the focal length or choose a focal length that suits you. In this case, I'm just going to choose, let's say, 3 or 7, 7 centimeters from the vertex. Okay, so from here to 0. And then also on the other side. And this point would therefore be your V, your focal or your focus. And then 7 centimeters still from there is is another point that we call twice the length of the focus, so 2f. Also on the other side, so somewhere here. So your 2f is somewhere here. Okay, once you're done with that, you can choose now one of the cases. In this case, I will choose case number 4. So case 4, this is a convex lens. Case 4, when the object is at 2f. Okay, so the object is at 2f. Now you're going to again decide on your own what will be the height of the object. For in my case, I will just choose a height that is 1 inch. So that's your object. And the object is placed at f, at not at 2f, but at f. Okay. Now once you're done with that, you can now go on with the ray diagram, which is again, first you start with a ray that's coming from the top of the um, arrow, and then you draw it such that it is parallel, the incident ray is parallel, and then it should reach the lens axis. Once it reaches the lens axis, it will pass through, it will be refracted such that it will pass through the focus. So something like that. Okay. And then the second axis will be the vertex, the vertex ray, which will be coming from the top, passing through the vertex. And again, this ray will never be refracted, will not be refracted. And then the FP ray. So the FP ray from the top towards the F, but if you continue, it will not reach the lens axis. So you stop there. Okay. Now in this case, notice that these lines are parallel. So if you move them forward, they are not going to meet. Even if you trace them backwards, they are also not going to meet. So in this case, we will just say that there is no image form because the light rays don't move forward. Don't meet when you move them forward. They don't even meet when they move them backwards because they are parallel to each other. Okay, so there is no image form. So in this case, the ray diagramming becomes very easy because you only get to draw two of the three rays, and then it just so happens that it in this case it doesn't create an image. Okay. However, your work is not done yet. The second part of the task is to prove that there's really no image form through the mathematical way of doing it. Okay. So before we drew our incident rays and refracted rays, we knew several things. We knew, for example, the focal length. So these are considered to be given. We knew the focal length because we measured it from here to here. If you remember, it was 7 centimeters from the vertex to the focus. And then now we know the object distance. P is object distance, so how far the object is from the vertex. If you notice, since your object is at F, then therefore the distance of it from the vertex should be the same as the focal length. So it should also be 7 centimeters. And then you can also know the height of the object because we set that. If you remember, we set that to be 1 inch. Right? We set that to be 1 inch. And that's all we know. We don't know the h prime or the height of the image because assuming we have not done the ray diagramming yet, so we have not, we don't know what the height of the image is. And we don't know q also, which is the image distance. Okay, so we're going to first solve for the q because that's the only thing that we can solve. Okay, and again it starts from the lens equation. The lens equation is 1 over f is equal to 1 over p plus 1 over q. Okay, so I want to solve for q, so I'm going to make this term on the other side. So I will have 1 over q is equal to 1 over f minus 1 over p. And then these two terms here, I want this to be one term, so I'm going to join these two fractions together. So this is their common denominator. Fp divided by f is p minus fp divided by p is f. So therefore 1 over q is p minus f over f times p. Now, I'm not trying to solve for 1 over q. I'm trying to solve for q. So remember that q is simply the inverse of 1 over q. So we simply flip that, it becomes q. So that means this, we also need to flip this. So instead of p minus f over fp, it will be fp divided by p minus f. That's your q. And then now I can now solve that because I have the values here. So the the P and the F are both 7 centimeters. Okay. Now take note that this is a convex mirror. And if you remember, have um, convex mirrors have positive foci. So that's why this focus here is positive 7. Now P is always going to be positive, right? So that would be it. And then here you will have P minus F, which is 7 minus 7. And obviously, this boils down to 49 centimeters squared over 7 minus 7 is 0. And there goes the problem here because 49, any number divided by 0 is undefined. Okay? So it would be undefined. So the Q is undefined. And why is the Q undefined? Because there's no image form, meaning Q is the object, the image distance. So if there's no image form, how can there be any image distance? Remember, zero distance is different from no distance at all. Because zero distance implies that there's an image, but the image is located at the vertex. But when you say undefined, that means there's really no definition for the distance of the image because there is no image in the first place. Okay? And then how about for uh, h prime? Well, let's continue. H prime over h equals negative q over p. Negative q over p. And then h prime is equal to, well, negative q over p times h. Then we can continue here. What is negative q? Unfortunately, it's undefined, so you cannot not proceed. So this also results to nothing. And again, why does it not result to anything? Well, it's because this is the height of the image. There is no image formed in this situation, so there should be no height of the image and no distance of the image. So that's the reason why when you do this stuff, you your mathematical calculation confirms what is shown in your diagram. If the diagram there's no image formed because they are parallel rays, then in the solution it would show somehow. Okay, so um, that would be it as an example for convex lens. Now, please remember that you will be doing 5 different cases for lenses. You will be placing the object beyond 2f. You would be placing it at 2f. You would be placing it between 2f and f, and then at f, and then finally between f and the vertex. Okay, so I just gave you one example, which is what happens if the object is at f. Okay, so I hope you are guided by that. Thank you.